Chapter 8, Regression Wisdom. Example 1. On investigating the relationship between height and weight, you've discovered a positive linear association that can be interpreted by linear regression. You find that r squared equals 0.46. Interpret the slope in context. Okay, r squared is our variation, so to find out the correlation, which it uses the letter r, we just take the square root. So since the r squared equals 0.46, the correlation must be its square root. Okay. Now keep in mind that when we take the square root of something, like if you have x squared equals 4, and we take the square root, we don't just get 2. We get 2 or negative 2, because a negative times a negative is positive. So the slope, if we take the square root, we need to know, is this slope going to be negative or positive? So the r squared gives us the r, but it doesn't give us the direction if it's positive or negative. In this case, we're told it's a positive linear association, so the slope will be positive. So furthermore, we are told the association is linear, which is important because that means we can talk about the correlation, and positive. So its slope, so it's appropriate to discuss the correlation. And it must be positive. Our correlation is 0.678. Okay, so we don't have the standard deviation of the x and the y, so I can't calculate the actual slope. So we've got to talk about these in standard deviations. This means because we have our standardized scores, so we're going to talk about what this means in terms of standardized scores. For every one standard deviation, a person's height is from the mean, because that is our explanatory variable. we would expect their weight to be 0.687 standard deviations from the mean weight. Let's throw an on average in there. And there you go. There is the slope in context in terms of the correlation.